Hello, welcome to our presentation. So this is about our smart greenhouse project. So I am Sheikh Ahmad Shah. This is a physical computing based tabletop automated greenhouse made of thin wood plank, as you can see in the figure A1, and recently we are also building it with 3D printing materials. Here students learn to code in MakeCode, which is an easy and intuitive block-based coding interface. We can show a bit of our code here. This is the total code that we use the students. Here, as you can see, we create the function for get data, and then we also have codes to show temperature, humidity, light, these things, and we also have codes like if air temperature is greater than our set high air temp, fan will turn on and off, and fan is connected to this P1. Similarly, we can code for light. So this is what students go through over 2 weeks of intervention. And after doing the coding part, students also use CodeApp, which is a very good data visualization tool. Let's look at CodeApp. So this is the CodeApp website, and we can import our data set, and as you can see, it populates a data set, and we can quickly create graph. So the easy thing to do is that we can just drag and drop. So we can drag time here, and we can drag temperature here, and we can see the dot, and we can connect the lines and it will show up like this. Similarly, we can also add humidity here, and we can see how temperature and humidity changes over time. So this is a very easy drag and drop data visualization interface that we use. And these are the components we use in our project. As you can see, microbit, and this is the crowtail shield. And this crowtail shield allows easy plug and play option for all these sensors. In this project, we students usually start up with using MakeCode to program microbit. Like they show up their names, or show up some number, or show up some icon, and then they learn how to control LED light. They can blink red and green and blue. So this is a very fun activity students like to do. And then they learn how to use sensor to collect data, and they also learn how to display those data on the screen. And then they automate fans and lights, as you have seen, like if temperature is high, then fan will turn on, something like that. And then at the last activity, they also collect data, and through collecting data, they can visualize the data in the CodeApp. We have found that this has positive impact on the students, and students' belief of their own competence of computing increases significantly. Also, we have found that students of the low scoring group, which actually had a lower score in the pre-test, their score increased in the post-test. But we have also found that students who actually had high scores, their scores actually dropped a bit. So we are thinking that it might have happened because they may overestimated their interest or competitivity, but actually when they have done it, then they understood, okay, maybe it's not that easy the way I imagined. So I think there can be some Dunning-Kruger effect. So we are still trying to explore why is this happening, but the good thing is the low scoring group are being benefited through this project. And we have also learned that students have different hooks. Sometimes students get hooked because of the love for plants. Some students are already in love of coding, so that gets them hooked. And some students like to build things, so when you use the wooden part, there is a building aspect that many students get really like. So we have found that we should have multiple pathways for engagement in a project. And we have also found that students really enjoy the LED strip activities. And some of the students also express their frustration, like as you can see, to use relays and different devices, lots of wires are used. So at one point it starts to become a bit confusing. So I think in future implementation we are thinking about how to reduce the wire management, and in the future this project is currently evolving into a transdisciplinary learning initiative where teachers with diverse subject areas are exploring innovative ways to integrate the smart greenhouse context into their classroom instruction. So that is what we are working on now with the teachers from Alabama, Maine, and from Massachusetts. And if you want to know more about our project, you can use the QR code that is presented here. Thank you for your interest.